everyone. Here we go. 1.3, lesson number 3 of the AP Environmental Science curriculum. So let's move through it. It's about aquatic biomes. We just finished talking about terrestrial biomes. So now we're going to be able to talk about some of those aquatic, similar type habitats across the planet. Again, like every lesson, we're going to talk about the essential knowledge we need to know from the College Board. So make sure you understand this. If you don't understand it, again, shoot me an email. It's really not that hard. Next, here we go. The aquatic biome. So what is an aquatic biome? Well, they actually going to take two major forms, aquatic biomes will. The first one is going to be what we call freshwater, all right? Meaning it has less than 3.5% or 3.5 parts per million saline, meaning salt. So it's not salty. This is fresh water. Then you have marine environments. Marine environments are going to be salty water. So that's the big difference. You either freshwater aquatic biomes or marine or saltwater aquatic biomes. Now, when we talk about freshwater biomes, we throw out two new words in there, lotic and lentic. And what they refer to is it flowing water or is it kind of standing water? Now, lotic, as in locomotion, is moving water. So these are going to be your streams, your creeks, your rivers, versus lentic, which is going to be standing water. So your ponds, your lakes, various different biomes like that. So let's talk about lotic freshwater biomes. These are going to be like your streams, your rivers, your creeks. And as the water flows through, it's actually going to experience some different characteristics. So flowing water is going to have different characteristics than standing water. And that's really big and important for us to understand. One of the big things is that the water is constantly mixing. Because the water is constantly mixing, it's going to be a uniform temperature. Oftentimes, the water is going to be cooler in temperature because it's going to flow through shaded regions. Because of that and that constant mixing, it is actually going to often be lower temperature. That's going to be really important for a lot of chemical parameters. One of the really interesting facts about water is that the colder the water is, up to 4 degrees Celsius, it actually can dissolve more gases within it. So the colder water can actually hold more dissolved gases, which is important for dissolved oxygen, something we're going to talk about in an aquatic ecosystem. How do aquatic organisms breathe? They're breathing in the aquatic oxygen dissolved in the water. It's also going to have higher dissolved oxygen, not just because it's cooler temperature, but because of something called riffling. Riffling is just when it flows over rocks. The more you can mix the air with water, it's going to dissolve more oxygen into the water. So it's really important to understand that one. Again, there's no major stratification occurring. So stratification being layering of temperatures. And oftentimes, lotic ecosystems are shallower than lentic ecosystems. So because it's flowing, yes, some of the major streams or some of the mountain streams, you get some narrow areas. You can have very, very deep rivers, deep creeks and stuff like that. But for the most part, it's shallower than that of standing water. Now compare that to lentic freshwater ecosystems. Lentic ecosystems like our lakes, ponds, bogs, and swamps. All of these have standing water. Now, when we talk about that standing water, you get different things. You're going to get stratified. How many of you have ever been to a lake or a pond in the summer and you've gone swimming and your upper body, when you're kind of floating in the water, treading water, your upper body is in the warm water and your feet are down in cold water? Well, that's stratification. There's actually different layers of water as you go down. Depending on how deep the water is, you can sometimes reach what's called an aphotic zone, an area where light cannot penetrate. And that right there is actually the difference between a pond and a lake. So if you've ever wondered what's the difference between a pond and a lake, well, a pond has a photic zone that goes all the way through. So even growing at the bottom, in the center, the deepest part, light can still reach it. That is a pond. And then you have a lake, which by definition has an aphotic zone, an area where light cannot penetrate through. All right, maybe it's due to just the depth, the mineral deposits, different things like that. But usually that's around 200, I believe it's 200 meters deep. We're going to get to it at the end of the slide here, where you kind of reach that aphotic zone. But that's a pretty deep pond or a pretty deep body of water. So sometimes it's other characteristics influencing it, like different debris and the turbidity of the water. There's often more aquatic vegetation in a lentic ecosystem. Why? Because it's not getting flushed out every time it gets a big rain. Think about all like aquatic plants. If they're not really root bound, they sometimes have what's called a hold fast, which like kelp has a hold fast, doesn't have a true root system. What happens is as you get flowing water, it's just going to pick it up and rip it up and move it. And so it gets flushed out to oftentimes to the marine ecosystems. And then sometimes, especially with our very unique ecosystems like our bogs and our swamps, you get very unique species. Sometimes they're very specialized to just that body of water. Some of our bogs are backwater bogs or mountain glacial bogs up in the Pocono regions. They have very, very unique organisms that are sometimes only found in that small geographic area because it's just this very small niche of an ecosystem that they've just evolved and adapted to. So let's talk about now marine biomes. Marine biomes are the largest classification of any biome on the planet. All right, mainly because oceans are included in it. Remember, oceans make up about 70% of the surface of the Earth. All right. When we talk about marine biomes, we're talking about oceans, marshlands, estuaries, coral reefs. All of those different ecosystems exist and survive with salt water. So let's talk about oceans. Oceans make up greater than 70% of the surface of the planet. They are expansive and large reservoirs of water. Water goes through its water cycling, which we're going to talk about in a couple lessons, but it's going to cycle its way back out to the oceans. Its massive, complex food systems are based off of photosynthetic organisms known as phytoplankton. Phytoplankton then is consumed by zooplankton, and then it starts to work its way up the food chain, the food web. It's incredibly important. The oceans are incredibly important, not just for the life that's found in the oceans, not just for recreation, but also for regulating this planet. The oceans are the #1 reservoir of dissolved carbon dioxide on the planet, so it stores more carbon dioxide than anywhere else, especially in the stone at the bottom. Like the actual bottom of the oceans is incredibly important for storing carbon dioxide. We also we just kind of finished talking about the terrestrial biomes, the influence the oceans have on land, especially if you are in close proximity to the oceans. The thermal regulation, because of the large amounts of water, actually helps to moderate a lot of the temperatures there. Now, when we talk about zonation of a body of water, especially like the ocean, we got to look at it in two different ways. One, you can go from the shoreline out, and the other way you can look at it is going from the top of the water down. So what we're going to look at this first slide is from shoreline out. Now, the big thing to understand is there's different zones. Now, depending on where you are around the planet, some of these zones are bigger or smaller, just the way the planet is kind of evolved through different weathering processes, through plate tectonic processes. First thing we're going to talk about is the intertidal zone. It's exactly what it sounds like. Intertidal. Well, we know that there are two different types of tides, high tide and low tide. High tide, low tide. The area in between, your intertidal zone. How many of you have ever been up to an area like along the New England coast where you have a rocky intertidal zone? You get the intertidal pools where you get small pools of water where you sometimes find starfish or urchins and different things like that. Same thing out in the Pacific Northwest. Around our area, New Jersey doesn't really have too many intertidal zones. You have the beach. The beach is your intertidal zone. So you can see the high water marks and the low water marks depending on algae and various things like that. The neritic zone. Neritic is referring to out to the continental shelf. Now, depending on where you are, the continental shelf can be in different areas. So depending on how far out you go, you'll get to different neritic zones. So off of our coast, off of Pennsylvania or off of New Jersey, we have a decent neritic zone. Compare that to some other areas like the Pacific coastline, there's a very, very small neritic zone. The oceanic zone is just the open ocean. Once you're off the continental shelf, just the open ocean, the deep water parts of the ocean. And then pelagic is just kind of talking about everything else. It's really just kind of the whole body of water of the ocean. So sometimes you'll hear people refer to different types of birds as pelagic birds. They're open ocean birds, maybe things like petrels and albatross. They just survive out in the open waters. Now, looking at oceanic zones vertically. Okay, now we're going to look at it vertically. Now, the big thing to understand when we're talking about vertically is temperature and sunlight. The closer you are to the surface of the ocean, it's going to be warmer. It's also going to get plenty of sunlight. As you go deeper, it's going to get darker. It's going to get colder. There's also going to be more pressure as you go deeper. So organisms are evolved for that. The first thing we're going to talk about is the photic zone. The photic zone is the top 200 meters. So I was right about the 200 meters. This is the depth that sunlight can penetrate. Now, as you go deeper in the water, it's not going to be as strong. But it's saying that sunlight can penetrate down to these depths. Is it strong enough for photosynthesis to occur all the way down 200 meters? It would have to be pristine water, and it'd have to be very specialized organisms that are going to photosynthesize at that depth. But for the most part, photosynthesis occurs probably within the first, I want to say, 50 to 100 meters of the ocean. Then you reach the aphotic zone. Aphotic is just pretty much everything below the photic zone. So everything kind of overlap there. The last thing we want to talk about is something called the benthic zone. It doesn't just apply to marine ecosystems. It doesn't just apply to oceans or nothing like that. It refers to any body of water. Benthic just refers to the bottom. What is the bottom made of? So like in the oceans, you might have rocks or sand. In a river, you might have rocks or small gravel. Slow-moving creeks and streams like Neshaminy Creek, you're probably going to have some muddy sections. You'll have sand and various things like that. Depending on what's at the bottom, different organisms can survive there. So there's different organisms that live in the benthic zone. So organisms actually survive within that gravel. If you think about how many of you have ever gone looking for crayfish, you're looking for a stream with a rocky bottom. And maybe it has some mud or silt mixed in there. So as you start to flip over rocks, you oftentimes will find different things. Anyone that's a fisherman knows that you've probably found different mayfly or caddisfly larvae or nymphs in those areas. And later on in the year, who knows, maybe we'll actually go out and be able to do labs and we'll see those type of things. So here's a look different, again, looking at the ocean, different types of organisms found in the ocean. A lot of our life forms in the ocean are going to be found in the upper section, that photic zone, that upper area of the ocean. As you go deeper down, organisms have to be evolved. They're not going to be based off of photosynthesis and a lot of the planktonic organisms. Instead, these are going to be looking for different things that have died and then are sinking down. And as they sink down, they're going to feed on that decomposing carcass and different things like that. The other thing about these organisms is they're adapted for the pressure. They talk about like a sperm whale can dive down something like 4,000 meters. It can dive down, and it's got a specially designed skull to help with the pressure. So it's, a lot of organisms all survive in these different, very, very unique ecosystems. And I'm sure if you've ever watched Finding Nemo, you've seen some of these, characterized displays. So you see like the anglerfish with the glowing lure to attract other fish in, and then it attacks them and stuff like that. So very, very interesting in that regard. Marshes, swamps, and bogs are standing fresh water. Now, depending on the vegetation in there, it actually is going to determine if it's a marsh, swamp, or a bog. Now, a lot of times people will kind of rename or move some of these around, but just for pure definition's sake, they actually have different characteristics. A marshland is dominated by grasses, so it's predominantly grasses, very, very few trees. A swamp is now going to have trees. So the difference between a swamp and a marshland is that you are going to have trees, whatnot. How many of you have ever gone up to the meadowlands of up near New Jersey where the Giants play? If you're driving up 95, way up there in northern Jersey, that's all marshlands. It's all grass, Phragmites, grasslands all out there. But then sometimes you'll see swamps, like some in our areas, we'll see some small swamps and wetlands, which are going to be dominated by trees. And then you get to a bog or a mire, depending on which continent you exist on. It's going to be identified by acidic conditions, usually because it was formed. A lot of our bogs in the Poconos have been formed when the glaciers were retreating from the last ice age. and it left behind some pretty acidic conditions. And that's where we get peat to form, which peat is the precursor to coal. So peat eventually piles up and builds up and eventually forms coal. An estuary, incredibly productive ecosystems estuaries are. They are areas where freshwater and saltwater mix. So it's the area where, like, the Delaware River coming out into the Delaware Bay, in that mixing area, or the Hudson going into the Atlantic Ocean, stuff like that. They're going to have just less than 3.5 salt level, but they're going to be more than zero. So we consider the water to be brackish. Brackish just refers to less than 3.5, so it's not true saltwater or marine ecosystem, but it's not freshwater, it's brackish, so it kind of fits that little area. There's a lot of threats from humans in these areas because people want to develop these areas. They want to build on this part area, so it's a lot of problems. And the other threats that they have are going to be dealing with incoming polluted water. So because usually it's coming from a large river, which we know a lot of people live near rivers, there's a lot of pollution that gets into those rivers, then that pollution gets into the estuaries. And hopefully, if the estuary is developed and in strong enough conditions, it actually can survive. So coral reefs, the tropical rainforests of the ocean. Coral reefs are home to 25% of the marine species will actually live there at some point in time in their life. Sometimes it's just for reproductive time. Sometimes it's for feeding, different things like that. So almost 1 out of every 4 aquatic organisms will find its way through a coral reef at some point in time. But yet they only make up 1% of the Earth's surface and less than about 2% of all of the marine ecosystems on the planet. They're incredibly important for humans because they actually are going to protect us. They actually have the ability to slow down approaching storms, lessen what we call the storm surge and the energy from the hurricane or a major storm coming in, and actually can protect island habitats and different areas. But it's under immense threat from humans. Humans are threatening the ecosystems because they're blowing it up because they want to have shipping lanes. So they literally are blowing corridors through coral reefs so they can bring their large ships through. They're hunted for different fish or coral because people want to have them on display in their office or in their restaurant or in their home, different things like that. They're being poisoned and hunted for the different species there. And then ecotourism is a way to benefit the ecosystems, but it actually can be detrimental too. Humans getting in there, brushing up against the coral, they could kill off the coral. But it's a way to help bring in revenue to help save the coral reef. So it's this balancing act. And we're going to get into ecotourism a little bit later on in the year in a way in which different habitats can be preserved. Coral reefs and how they actually protect everything. So I was just mentioning how they can lessen the storm surge. 95% of the energy actually can be reduced by having an intact coral reef system. So it's beneficial to have them there. And it actually will reduce the wave height. So what it does is it helps to crest the storms early so they don't crest right on the land and bring all that energy to land. One of the last ecosystems I want to talk about is a mangrove forest. Now, it's kind of weird to talk about a forest when I'm talking about aquatic ecosystems. But the mangrove forest is actually incredibly evolved in that it can survive right along the shoreline. So mangroves thrive right along shorelines, especially in tropical intertidal zones. They have the ability to take salt out of the water, and therefore they can kind of take in salt water and use it for photosynthesis and to grow. Now, do they grow really, really rapidly? No, because they're spending a lot of energy getting their fresh water, but they can survive here. They're incredibly important for ecosystem stability. They help to stabilize the shoreline because they're all in here. They actually help hold the sand in place, so it cuts down on the erosion and allows for a lot of organisms to live there. So a lot of organisms will get shelter from predators. They will be able to survive there. They reproduce there, and it just gives them that protection. It's under an immense threat from humans, however. Humans don't want to buy a beach property and have just forest there. When you buy a beach, you want to be able to walk on the sand. So what do people do is they cut down all these mangroves. And again, they're so slow growing, it's not like they can just come back. It's not like you can just dig one of these up and plant them. They have an immense intertwined root system that helps to stabilize and create this network underwater. But people cut these down and then they go and expect, their beach to be there, but the first storm that comes through now washes away their entire beach. So it's something that as a society, hopefully we are addressing and moving forward. And I want you guys to be aware of what mangroves are and why they're coming under threat. So, recapping 1.3, aquatic biomes. Do you know the difference between a freshwater and a marine biome? Hopefully. Can you identify the horizontal zones of the aquatic ecosystem? Hopefully. Can you understand the vertical zones, the photic, aphotic, and benthic zones? Hopefully. And then last, do you know the different aquatic biomes? Do you know the difference between marshes, swamplands, bogs, open ocean, lotic, lentic, all those different ones? Hopefully. And if you don't, just shoot me an email. All right, that's all I got from 1.3. I'll see you next time at 1.4.
You like that lesson? I know you did. So why don't you go ahead and smash that like button right now. Go ahead and comment. Tell all your friends about how great that lesson was. And make sure you subscribe, because I'm going to keep bringing you AP environmental content that you're going to want to watch. Or do whatever else those other YouTube channels tell you to do. And with that, Maloney.